3 telescopes in the atmosphere. Okay, so let's go forward. Okay, so where would you want to build a giant telescope? Because when you build those giant telescopes, like a 10-meter large one, 30 feet diameter, you don't just transport those things around. So where are you going to build it if you're going to build something that big? Like, you got to pick somewhere specific, and you want to pick the best place, because you don't want to pick somewhere really bad to build this telescope, and it doesn't work very well. So what are the conditions that you would want to build a giant telescope? Okay, so think about that. And the things you're going to want to do is you're going to want to look at somewhere that's calm. Okay? So remember I was talking about how there's layers of atmosphere? Wind moves the air around, and when you move the air around, remember I was saying the light gets refracted going through that air. Well, you want the air to be as still as possible, so the light coming through it doesn't refract very much. If the wind is moving around the air everywhere, that light is going to get refracted everywhere. So a twinkling star might look more twinkly if it's real windy outside and it's moving the air around a lot. Okay. Next thing, you would want it to be very high. Okay, so you want to build it on like a mountain, because you want it to go through the least amount of atmosphere as possible, because the atmosphere is what messes it up. It makes things twinkle, it bends light. You don't want any of that, so build it on top of a mountain where there's less in between you and the sky. Okay, another thing, you want it to be dark. Okay, light pollution is a horrible, horrible thing for astronomers. Like in New York, if you go to New York City, just think about El Paso. If you look up at night, you don't see a ton of stars. I mean, you see stars, but you don't see a bunch of them. And if you go to New York City and you look up, you don't see any stars, okay? So the amount of light in the atmosphere on a low level like where we are, will completely ruin the ability to see stars. So you would want to build it out in the middle of nowhere where it's completely dark and you can see a great view of everything overhead, okay? And the last thing is you want it to be very dry, okay? When there's water and air, water refracts light more than when there's no water, okay? So water refracts light a lot. Like you've seen rainbows. Rainbows come from light being refracted and then shot back towards you, and it breaks up the colors, okay? So you don't want there to be a lot of water in the air. So if you look at all those things, you want it to be calm, high, dark, and dry. Calm, high, dark, and dry. Okay, so, I don't know about you guys, but it sounds like a desert to me. A very mountainous desert is what you would want to build this on. And we live in a very mountainous desert. So that's why we have the second largest telescope in the world not too far from us, is because we're very dry. At night it is extremely dark if you go out into the middle of the desert, right? And we are one of the least populated areas in the United States of America in terms of like things around us. Like, think about the largest big city near us. I think it's probably, like, big city would be Phoenix. I mean, it's far. And you also got, like, Albuquerque, but even that's hours away. So we're a perfect area to be building this thing. Okay? And let's go forward. Okay. Here's the one in Fort Davis. I took a picture of it and I brought it onto here. So this is the one closest to us. It's the second largest in the world. The second largest one is the one over here, actually. These were ones built in the 60s that are very big. Okay, don't get me wrong, but that's the largest one in the back there. And then this is the one on top of Hawaii, the Keck telescope. And they built it here because it's so extremely high altitude. I've heard astronomers and people talk about driving up to it. If you can see this, look, it sits above the clouds. They say as you're driving to it, you look up and you think, oh, we're not going to be able to see anything. It's so cloudy. And then as you drive through the clouds and you come out of the clouds on top, you're just like, oh my goodness, this is beautiful. And so they built it on top of the Hawaii island because it is so high altitude. And they actually want to build another one up there. It's called the TMT. It stands for 30-meter telescope, so it would be 3 times larger than the largest telescope right now. And they're running into a whole bunch of problems because the Hawaiians don't want it there. They say it's a very religious mountain for them, and they don't want them building on top of it anymore. And so the astronomers are running into problems with that. Okay, so why would we want to put a telescope into space? Yeah, so I mean, I think the very obvious thing is almost everything I spoke about, the problem was the atmosphere. The atmosphere ruins images. So if you can just get above the atmosphere, you're good. Like there's nothing to ruin the images. There's nothing to refract the light. So that's why we want to put telescopes into space, is because there's no atmosphere to refract the light and ruin the image. So this is a picture of Hubble telescope. It's about I think 3 meters in diameter. So it's not a very huge telescope if you compare it to telescopes here on Earth. Our telescopes here on Earth are gigantic because we have to make up for the fact that we're seeing through tons and tons of air, when this thing does not need to worry about that. Okay, and so here's the next largest one. Hubble is going to be replaced here pretty soon. It's called the James Webb Telescope, and they're even putting it further out. They're putting it out past the moon's orbit. Okay, and this thing's going to be huge. Okay, and it should be able to see. The thing that blew my mind the most was they said that they would be able to see the atmospheres of different planets not orbiting around our sun, which is just unbelievable to me. So this thing's going to be gigantic. Okay, going forward. So now we have different telescopes in space to look at a bunch of different types of light. Okay, so the Hubble is the one that looks at visible light. And it's the most popular because, I mean, we like to look at things that we can see with our eyes. But there's the Fermi telescope that looks at gamma rays, the Swift that looks at X-rays, Chandra looks at ultraviolet and I think some visible light. And then the James Webb telescope, that's the one going up, that's going to be looking at visible light, but it's going to be much bigger than the Hubble. And the Planck telescope looks at radio waves, if I remember correctly. No, it looks at microwaves. The radio waves, most of the radio waves we pick up, we use giant telescopes on Earth for that. Okay, so if you look at this, they're showing how far gamma rays make it down into the atmosphere. Gamma rays don't make it to the Earth's surface, which is good, because if gamma rays did, we wouldn't be alive very long, okay? So our atmosphere protects us from gamma rays, X-rays, and a lot of ultraviolet rays. Some ultraviolet make it down. I mean, that's how we get sunburns. But it blocks out most ultraviolet rays. That's what the ozone layer does. And then infrared's pretty much blocked out all the way to radio waves. So only light that makes it to Earth's surface from the entire electromagnetic spectrum is the visible light and the radio waves. Okay, those are the only ones that really make it down to Earth, and that's why our eyes pick up visible light. We've evolved to use that spectrum of the electromagnetic spectrum to pick up things. Yeah, so that's why we can have visible light telescopes on Earth and we can have radio telescopes on Earth, but we can't have anything else. It would be really dumb to build an gamma ray telescope on Earth, because you're not picking up any gamma rays. So you wouldn't see anything. So there's no point in building a gamma ray telescope here on Earth. If you're going to build a gamma ray telescope, you got to send it into space so the atmosphere doesn't block it out. Okay? And that is everything. Going on to 6.4.